if 97.2 grams magnesium metal reacts with 128.0 grams oxygen gas, then how many grams of magnesium oxide, the only product, are formed? And the answer is D, 161.2 grams. When you read this question, you might think that the answer should be the product would weigh the sum of the masses of the two reactants. So 97.2 grams plus 128.0 grams, that would be the mass of the product. And that would be 225.2 grams. So if you thought the answer was B, then you made a common mistake. What happens is one of these chemicals doesn't fully react. So this is a limiting reactant problem, and one of the reactants is an excess and the other one is the limiting reactant. You can recognize limiting reactant problems when you have a certain amount of both of the reactants, and what normally happens is one of them is an excess and the other one fully reacts. The one that fully reacts is the limiting reactant. So this is a limiting reactant problem, and it takes a little more thought to solve this. But first of all, we need the balanced chemical equation in order to solve this problem. So you know the two reactants, magnesium metal and oxygen gas, and it tells you what the only product is. So we ought to be able to get the balanced chemical equation. So that's the first step to get the balanced chemical equation. You have magnesium metal reacting with oxygen gas. Oxygen gas comes in the form of O2, and the product is magnesium oxide. So magnesium oxide has the formula MgO. And I'll remind you that magnesium oxide is an ionic compound, and you should know that magnesium is a +2 ion and oxygen is a -2 ion. And so therefore it balances, and you only need one magnesium per oxygen, and the formula is MgO. So that's something that you need to be able to do. If you're given the name of a compound, you should be able to write the formula of the compound. So this is magnesium oxide. So now that you know the identity of the chemicals in the chemical equation, you can then add coefficients to balance it. And the coefficients are 2, 1, and 2. So here is the balanced chemical equation. Now that we have that, we can solve the limiting reactant problem. One approach, which is the approach that I prefer for solving the limiting reactant problem, is to just do the reaction calculation twice. And what you do is you start with the one reactant, the 97.2 grams of magnesium metal. If all of that reacts, then what is the product yield? And then starting with the other reactant, if all of the 128.0 grams oxygen gas reacts, then how much product yield would that result in? And then it turns out that one of the answers is going to be the correct one. So let's start with the magnesium. 97.2 grams of magnesium. If you look up magnesium on the periodic table, its atomic mass is 24.3 grams. So 1 mole of magnesium is 24.3 grams. And when you take your mass that you start with and multiplying it by this conversion factor, 97.2 over 24.3, you should be able to do that without a calculator. That comes out to 4. So what you have here is 4 moles of magnesium. And then from the stoichiometry of the equation, 2 moles of magnesium result in 2 moles of magnesium oxide. So it's a 2-to-2 ratio. And so up to here, we now have determined that this would result in 4 moles of magnesium oxide. And then to convert it back to grams of magnesium oxide, we know that 1 mole is 40.3 grams. If you add oxygen, which is 16, to magnesium's 24.3, that comes out to 40.3. So this last conversion factor gets you to grams of magnesium oxide. And so when you take this and you multiply it by the 4, that gets 161.2 grams of magnesium oxide. Now, this is a limiting reactant problem, and that means we need to do the calculation again using the other chemical. So let's start with the 128.0 grams of O2 now, and convert that to moles using the molar mass of O2. I'll remind you that 2 times the atomic mass of oxygen, which is 16, gives you 32. So 1 mole is 32 grams. And you can see that 128 over 32 is 4 again. So we're starting out with 4 moles of O2. And this time it's a 1-to-2 ratio from the chemical equation. So that's 1 to 2. And then when we take 4 times 2, that gives us 8 moles of magnesium oxide product. Now at this point, you should know that the first one is going to give you the right answer. But just to carry through and finish the calculation to get to grams, we have 8 moles of magnesium oxide converted to grams gives us 322.4 grams of magnesium oxide. And out of these two answers, it's always the lesser amount. So it turns out that magnesium is the limiting reactant and the oxygen is in excess. The one that results in the lesser amount of product is the limiting reactant. And you know that this is the right answer for a couple of reasons. First of all, you have enough oxygen available to get you 322.4 grams of magnesium oxide, but you only have enough magnesium available to get you to 161.2 grams. So once you form this many grams of product, your magnesium is done. You can't form any more product, but you got oxygen enough to get you more product than that, up to 322.4. So using that thought, the magnesium being done, that will be the amount of product you get. And second, you know that that this answer cannot be correct because that's more mass than what you started with. You know you can't form more product mass than the combined mass of all of the reactants, so you know that one's not going to be the answer too. But even though this is the way that you solve the limiting reactant problem, you do the calculation twice, and the lesser amount is the correct answer. So here, the amount is 161.2 grams. Now, you might have chosen another answer. You can see that here the 322.4 shows up as a possible answer. The 225.2 grams, that's what you get if you just add the two masses. And so there are a couple of curveballs here, and it turns out that this is the correct answer, which is D. So kind of tricky.